solving systems of equations by elimination. This is the third and last way to solve systems that we learned this year. And for most of my students anyways, I think this is one that they liked. Substitution is the least favorite. What we're doing with elimination is we are trying to get something to eliminate. And the way we get things to eliminate is to cancel them. And the way they cancel is because they have the same coefficient, but a different sign. So what I mean by that is 3x and negative 3x would cancel. Or if you had negative 7y, you would need a positive 7y for those to cancel. So they have to be the same coefficient, but opposite signs. If you had 3x and 3x, those are not going to cancel. If you combine those together, you're going to end up with 6x. So you have to remember that one of them needs to be positive and one of them needs to be negative. So that's just some side information. Here's an example for us. So when you look through, you need to decide what are you going to eliminate. Some things will eliminate right off. This one won't, because right here, if we combine them together, they're opposite signs, but they're not the same coefficient. Same thing right here with the y's. They are opposite signs, but the coefficients are different. So we would need to get them to be the same. If you need to make a change, you're allowed to, as long as you multiply everything in that line by the same value. And as long as your signs are opposite, it doesn't really matter what numbers you get them to be. So when I look at this, I could get both of these to be 12. I could even get both of them to be 24. The smaller the better, because it just means that your numbers are a little bit lower and they're typically easier to deal with. So when I look at this, I'm thinking right off the bat that all I need here is a 2. So I'm going to multiply this line by 2. And if I multiply this line by 2, then my new second line is going to be 2x minus 8y equals negative 24. And I'm just going to keep my first line the same. I don't want to make any changes to that one, so I'm just going to rewrite it. Equals 14. So now what we're going to do is combine these together, and we say we combine them by adding, but you do have to pay attention to the positives and negatives. So a negative 2x with a positive 2x is going to cancel. A 3y with a negative 8y is going to be negative 5y. And 14 with a negative 24 is going to be a negative 10. So now we can solve by dividing by negative 5 on both sides. So those cancel. And we get y equals 2. So right here, I'd ask you if you were finished, and the answer would be no, because we know these two lines are going to meet at a point, because we got half of an answer. So if we set up our ordered pair, we got y equals 2. So we need to make sure that we put the 2 in the correct spot, and that goes back there. Now we need to figure out what x is. So we can go up here and use either problem. It doesn't matter. I'm going to use the second one. So I don't know what x is. I know y is 2. So what this is telling me right here to do is to multiply negative 4 times 2. So that's going to be a negative 8 equals negative 12. So to solve, I need to add 8 to both sides. So that cancels. And x is negative 4. So now I'm going to go over here and fill in my ordered pair with negative 4, 2. So I know that this is the point where these two lines meet. And that's called elimination. Sometimes you may need to multiply both lines by a number to get something to cancel. And sometimes you won't need to multiply at all. It will just cancel from the beginning. But the goal is to get one of the variables to cancel, which is why it's called elimination. You're trying to eliminate one of the variables so you can solve.